Hi, in this tutorial, we shall cover some of the best practices with regards to Docker, especially in production environments. To make things a bit interesting, not only shall we mention the best practices, but where possible, we shall do a practical demonstration of what each best practice entails. I will make a few assumptions before we begin. 1. You have a basic idea of what Docker, images, and the whole concept of containerization is. 2. You have Docker installed in a local machine. And 3. You have an IDE of your liking. I'll be using VS Code. With that out of the way, let's begin. So best practice number 1 is avoid when possible the use of the default Docker latest tag. Images need to be tagged appropriately. A tag is a label on the Docker image which provides the use of the image with some useful and at times important information about the image or version of the image they are using. It's not advisable to use the latest tag, which is provided by Docker as the default tag, especially when deploying images in production environments. This is because Docker will, by default, tag an image with the latest tag if at all you don't specify a tag when you are building or pulling the image. This can be very misleading and cause a mix-up to a team of software engineers pushing images to a shared registry or deploying to environments multiple times in a day, as you're about to witness shortly. It's now time for a quick demo. So in your terminal or command line, create a working directory. Let's call ours latest tag. So here I can just say make the latest tag, then ICD into latest tag. Then open your IDE of choice. Since I'm using VS Code, I can open it with the alias code dot. Then in your IDE, create a Docker file. So this Docker file is going to be for a fictional product or service we're building. We will simply leverage the lightweight Alpine Docker image and create a container running a simple shell script that prints out text stating the version of our service. So in the root directory here, just create a Docker file. So let's start with the base image. We can say from the base image we're going to use is Alpine 315.0. We're going to add an argument pointing to the home directory. In our case, it's going to be /app. So you can say argument name here is going to be app_home. That's going to point to /app. Then we're going to pass the app home argument to the working directory command to set it as the working directory. So you can just say here work there or work there. Set that to app home. It's supposed to be work with a K. Set it to app home. Then we're going to declare a simple script which just outputs a text stating the version of our product or service. So we can just say run echo, then have the shebang like that. Bin, this is going to be shell script, sh, then n, and then the caret sign, point that to this file, create this file, don't use latest dot shell script like that. Then you're going to have another run command. So here you're going to say run echo. And here now we're going to echo the text. So this first line here, we're creating the shell script. Then here now we are echoing the text. So here you can say echo. There you can say pull requests are welcome as this is version 1. You can put whatever text you want there. Then close that. Then add a quotation mark and then double caret sign, and you can say pass that to don't use latest.sh. Then I'm going to declare an entry point. So the executable here is going to be the shell script. Sorry, the shell script we are referring to is don't use latest.sh. With that done, back in the terminal, make sure you're in the same directory as the Docker file and build the image. Feel free to give it any name. We shall call ours alpha/use latest tag. Let's go back to the terminal here and say docker build-t alpha use latest tag, and then point it to the current directory, the dot, that. Good. So once built, run the image. So let me clear my terminal. Here I can just say docker run alpha/use latest tag. As expected, we should get an output from our shell script stating that pull requests are welcome as this is version 1, as you can see. So remember, when we first built our image here, we did not tag it. This is important to note. We shall soon see why. So now let's add a tag to this image. We can come back in our terminal and say docker let's tag alpha use latest tag and tag it as version 1. So you say docker tag alpha use latest tag space alpha use latest tag it as version 1 like that. Then back in our fictional project, let's say we have pull requests that have been merged and thus we need to build a version 2 of our product. So let's amend our Docker file and change the text from version 1 to version 2. So come here and then let's say, here you can say pull requests are no longer accepted. And then I can say we are in version 2. So here I can just say we are in version 2. Then save this Docker file. Then let's build the amended Docker file, this time tagging it as version 2 right at the point that it's being built. So we can go back to terminal and say docker build -t, then say alpha, use latest tag. This time we tag this as version 2, then add the dot. Remember, when we first ran our build command with the docker run alpha use latest tag, since we didn't specify a tag like we later on did, Docker by default tagged that as the latest. Remember, in the next subsequent commands we tagged version 1 then version 2. But here, since we didn't do any tagging, Docker automatically tagged this as latest. Without specifying the correct tag, Docker will run what is the most recent version of the image that was tagged with latest. So according to our project, this is supposed to be our latest. So you would assume that if you want to run this latest tag, we just run, you can just say like docker run alpha use latest tag. And if you run that, it's so wrong, it will still point you to version 1 because this is what Docker tag does, latest. So to see the actual latest version of the image, so you can say docker run alpha use latest tag, then you have to add the latest tag like that. Now we get the same image, we get the same message. To get version 2, you say just have the same command, and then you can say version 2. Good. If you want to run version 1, the same. Good. So from this simple demonstration, you can see how using the latest version may cause a mix-up or confusion in terms of versions of your services or products running across your production environment. This is because you'd assume that the word latest has the same meaning as it does in English, meaning get the latest image that has the most current change or code. As you have seen, this is not necessarily the case when using Docker. So there's a solution to this. In medium to large organizations with large development teams working on projects with increased complexity, it's recommended that the development team agrees on a standardized tagging policy. This policy should be agreed upon as early as possible so as to avoid the tagging related confusion we have just witnessed. Most development teams use semantic versioning, which has 3 parts. That is, the major release version, dot, the minor release version, dot, the patch. So if you take an example of the Alpine image you'd used before, so we had used 3.15.0. So 3 stands for the major release version, then 1.5 is the minor release version, and then 0 means it has no patches. Best practice number 2. Don't run your containers as the default root user in production. Let's face it, as much as we want to believe that we are all good, there are some very bad programmers out there who will want to compromise and or attack your system or containers. It is thus critical from a security standpoint to reduce what an attacker can do if at all they manage to get access to your system. It's important to know that Docker, by default, runs processes in your containers as the root user who has all the privileges to do anything within the container. Being a root user on your container is the same as being the root user on the underlying host machine. Thus, the types of command an attacker can run on the container are limited to the level of access the user who is running the process on the container has. So, if there is no root or elevated privileges on the running container, this limits what an attacker can do. It's now time for a quick demo. In your terminal, create a working directory and change it to that directory. So let's call our security. Let's say make directory. We're going to call this security. And then you're going to cd into security. Then we're going to start our IDE. So I can just say code dot. Then let's create an Alpine based Docker file like we did in the previous section on tagging. But this time we shall be running a script to show us the memory information of our container. So let's go back to IDE. I'll create a new file here. Just going to call this Docker file. Then from Alpine. The base image is Alpine 3.15.0. Then as usual, we're going to have our argument for up home. Then we're going to declare working directory. This is just going to be up home. Then we're going to have a run command. So you can say run apk update. Next, we're going to install nmap, which allows for viewing of network processes. An attacker could use nmap to scan the network for open ports and network targets. We can say run apk add wget doing cal nmap, and then you're also going to install libcap. So libcap basically allows for viewing of container capabilities. So you can say libcap Then next, we're going to create a simple script which uses the mem.info, mp-start, and pmap to show details of the container's memory status. You can say run echo, then sh. Whoa, supposed to be a / here, sh, then \n, then create the file is going to be called show memory.sh. Then we're going to run again echo. This time we're going to say cat /proc /mem.info, then mp start, and then pmap like that, -x1, then carets show memory sh like that. Then we're going to run mod 755 on show memory sh. So 755 means read and execute access for everyone and also write access for the owner of the file. Then lastly, as usual, command cmd, and you can say here shell. The file is going to be called show memory.sh like that. Then save that file. So back in the terminal in the same directory as the Docker file, let's build this image. So we're in the same directory, so you can say docker build -t. Let's call this app insecure app, then have the dot at the end. Nice. Then next we're going to run the insecure app image. So we can say docker run insecure app. Okay, so we get an error. We can't run show memory.sh. Now the problem. So if you come back here, let's say that our app directory is going to be /app. So we need to run this from /app/show memory. Save the Docker file. Then let's run this again. You can say docker run insecure app. And this time it runs. Basically, you should see an output with great details about the container's memory information, plus all other related information that a root user has access to. To see who is currently running the process in the container, let's confirm that it's actually the root user. So you can say docker run --rm insecure app. Then who am I? As you can see, the response is the root user. So to see all the processes that the root user is able to run in the container, we are going to use the cap sh command. So you can say docker run --rm -it on insecure app, then say cap sh, then print. As you can see, the root user has privilege to very high level processes, which can pose a massive security vulnerability in a running environment. Such privileges include one to change ownership of files, that is cap chon, make changes to DNS, cap, that is cap net bind service, among all the others that are shown here. Earlier, we had installed nmap in our container, so let's assume we are an attacker. With the containers running as the root users as they are now, we could use nmap to scan the network for any open ports and network targets. Please note that nmap doesn't find any open networks, but it is an elevated command that shouldn't be accessible by any user who is not the root user. So how do you do this? You can say docker run --rm -it, -it insecure app, then sh -c, then let's run nmap and -s capital S on the port of 443 localhost like that. Good. You should get an output that resembles this. So we've basically been able to use the root user to scan the network for any open ports. So how do we solve this? To prevent such access, it's advisable to create a new user and add that user to a group. For example, let's amend our Docker file to reflect this. We shall create another user called alpha and then add the user to a group called insecure. So let's go back to our Docker file here. What you can do, let's change some stuff. So actually, let's have these run commands up at the top. And then after declaring our working directory, we're going to add a user called alpha to a group called secure. So you can say run add group, the add group --system secure, and then we're going to add the user. So add user to system in group. The group is going to be called secure, and add the user called alpha to it. And then what you're going to do now after the change mode, after 755, we're going to make the alpha user the owner of the working directory. So we can say run change ownership of alpha in the group secure to the working directory. And then lastly, we're going to switch to the newly created user. You can say user is alpha. Then that's it. So let's save this file. Then let's build our image again. So go back to your terminal and say docker build -t insecure app. Good. We're going to run the whoami command to see which user is running the container process this time round. So let's clear the terminal. Then you can say docker run --rm insecure app whoami. This time you see it's our newly created user alpha. So with the root user, we're able to run nmap from the container. So let's verify that this new user is not able to. So we can say docker run --rm -it insecure app. We're going to run the same command, shc nmap on the port 443 on localhost. Good. Now we get an error message telling us you requested a scan type which requires root privileges. So it is quitting. Remember now we are running our containers as a alpha user. That's basically how you'd add a new user to a group with limited privileges. As you have seen, running containers as a non-root user is very important, especially in a production environment. Please note that most processes running on the container are applications that don't need root access, and this is the same as the running processes on the server, where you would not run them as root either. Best practice number 3, find and fix security vulnerabilities in your Docker images. It's good practice to run tests against images to find vulnerabilities and learn how to fix them. One of the commonly used tools as of now is called Sneak. Security scans play an important role in not only ensuring the uptime of your applications, but also making sure you're not running outdated, unpatched, or vulnerable container images. It doesn't matter if you have created them from scratch and you trust them, still an important step in reducing the potential risk within your environment. We are now going to scan our previously created insecure app image to ensure that the security vulnerability of running as a non-root user that we fixed was done right and that no more vulnerabilities exist. So in your terminal, let's clear this. You can say docker scan insecure app. Good. So if you're running this for the first time, you'll be prompted to allow Sneak, which is an online software as a service, which helps in scanning Docker images to scan. Please allow that and it should start testing your insecure app, and you should get the results saying tested 30 dependencies for non-vulnerabilities and no vulnerable parts were found. So as at now, the security fix for insecure app was fixed correctly, and we've scanned it and no issues exist. Best practice number 4, using multi-stage builds. Before multi-stage builds, there was the builder pattern. The builder pattern involved having one Docker file to use for development, which contained everything needed to build your application, and a slimmed down version for use in production, which only contained your application and exactly what was needed to run it. Maintaining 2 Docker files is not ideal. One of the most challenging things about building images is keeping the image size down. Each instruction in the Docker file adds a layer to the image, and you need to remember to clean up any artifacts you don't need before moving on to the next layer. With multi-stage builds, you use multiple from statements in a Docker file. Each from instruction can use a different base, and each of them begins a new stage of the build. You can selectively copy artifacts from one stage to another, leaving behind everything you don't want in the final image. Each of your build stages can be named by adding an as keyword to the from instruction. Let's create sample Docker files for both a Python and a Node.js project to demonstrate multi-stage builds. Please note, these Docker files are samples and thus not complete Docker files. They are just for illustrative purposes. So in a terminal, let's create a directory and call this samples, then cd into samples. Then let's open this in our IDE. So with our IDE opened, let's create a new folder. We'll call this Python. Create a new folder here. We're going to call this Python. Then within the Python directory, create a new file. This is going to be called Docker file. Like that. Then you can start it off. An argument. The first argument is going to be for the Python version. So you can say Python underscore version. Let's use 3.9 slim. 3.9-slim bullseye. So we're going to create an alias for our specific Python version to be used in the file. So you can say from Python, then bring in the Python version, copy this, make it Python. So you just say as Python, that's the alias. Then we can now declare the build stage. So you can say from, as I had said before, with multi-stage builds, you have multiple from statements. You can say from Python as Python build stage. You can have an argument here. Let's say build environment. Let's say build underscore environment. So let's say this is for local development. Then we can install some apt packages, and we're going to use the -y switch to ensure the build does not stop and ask for any user prompt. You can say run apt get update and apt get install, and say no install recommends -y, then tap that in, so you can have build essential. Supposed to be tapped in. You can say build essential. So those are the dependencies for building Python packages. Then we can have libbq. That's for scopg2 dependency. Good. And then we can now install our requirements. So you can say here copy./requirements to the working directory. That's dot. Then we're going to create a Python dependency and subdependency wheels. So you can say run pip wheel -- wheel directory, which is /user /src /app /wheels. And you can say -r, bring in the build environment .txt. Then now we can have the Python run stage. So this was the build stage. Now let's declare the run stage. So here we can just say now another multiple from statement. So you can say from Python as the Python, now this is the run stage. Here we're going to have an argument for build environment. So we are still in local. Then another argument here for the app home, which is /app. Then we're going to set some environment variables. And say env. The first one is Python don't write bytecode. Set that value to 1, which basically means prevent Python from writing .pyc files to disk. Then you can have another env, call this Python and buffered. Set that value to 1. So basically means that the Python output is transmitted directly to the terminal without being buffered. Then next you can have another env. The environment is build_env. Bring in the build environment variable. And then we can set the working directory. You can say work directory. This can be app home. Then we're going to copy the dependency wheels. So you can say copy from the Python build stage. Copy that to /user /src /app /wheels. Copy that to /wheels. Then you're going to use wheels to install Python dependencies. So you can say run pip install no cache directory no index --find links, which is /wheels then /wheels and star, then /, then we can say and remove recursively -rf wheels once that's done. And then lastly, copy application code. So copy application code to the working directory. Then lastly, have an entry point. So the executable here is just going to be, let's say we have a script that is called ENTRYPOINT. This is how you'd basically set up like a multi-stage build Docker file for Python. If you want to get detailed information of how to do this in a development and in a production environment, I have a course on Udemy that goes in depth into this. And next, let's create a sample Node.js multi-stage build. So let's create a folder here. Create a new folder. We're going to call this Node.js. Then create a new file here. This is going to be Docker file. Then let's go back to the Python. We're going to start with an argument again. So let's just copy first argument. The argument here is going to be node version. And the node version we're going to be using is 16.14 Alpine. Then as usual, you create an alias for a specific Node.js version to be used in the file. So as we did in the Python file, let's just say from node. You can say from node, then the node version as node. Then let's say this is our build stage. So you can say from, let's assume this was a build stage. So you can say from node as node staging build. Create another argument for the working directory. So you can say argument app home. This time is /user /src /app, like that. Then you can declare the working directory. So the working directory is going to be app home. Then you can copy package.json. So copy package.json. Then what you can do, you can run npm install. Then copy our code to the working directory, which is in app home, like that. Then we can run. Then you can run npm run build. Then let's say we have another build stage. Here, let's assume this is now for production. So you can say from node as node production build. We're going to have an argument. The argument app home is going to be the pointing now, this time in production, to /app. Then let's say working directory is still going to be app home. Then you can copy package.json. Then run npm install. Then you can now let's copy from our build stage. So you can say from copy from node staging build. What did you call it? Node staging build. Okay, so from node staging build, copy that to /user /src /app /distribution. Copy that to /distribution. Then we can expose a port if you so wish. We'll just have expose 1998. Then the last cmd command, run npm start, like that. So this is ideally a typical example of how to use multi-stage builds both in Python and in Node.js. But please remember, these Docker files are still incomplete, but just wanted to give you a brief snapshot of how to do it. So don't take this and use it as it is. There's still more that can be done to this, depending on which project or application you're working with. Best practice number 5 is run one service per container. It's good practice in modern microservice architecture to run one service per container. The container's main process is set by the entry point or cmd command at the end of a Docker file. We have used both entry point and cmd commands in our previous examples. A golden rule of thumb when working with containers borrows from the single responsibility principle. That is, your container should have a single responsibility. If it's responsible for doing more than one thing, then it should be broken down into different services. When we limit what a container can do, 1. We reduce the resources being used by the image and thus reduce the size of the image. 2. We also reduce the chances of a hacker being able to perform anything they shouldn't if they gain access to a running container. 3. It also means that if the container stops working for some reason, there is a limited effect on the rest of the other applications running on the environment, and thus the service can easily be rebooted or recovered. Best practice number 6. Keep unnecessary files out of your images. When working with the usual Git workflow, we use a .gitignore file to avoid polluting our Git repositories with unnecessary files and/or secret credentials. With Docker, it's best practice to also use a .dockerignore file. By using a .dockerignore file, you can reduce your image size, speed up your Docker builds, and it can also help you avoid exposing your secret files or credentials. Here is how a sample .dockerignore file would look like. Best practice number 7. Don't build configuration and secret environment variables to your images. Never build your project environment variables and secret credentials or configuration into your Docker image. Building your images with these credentials poses a security risk, since they will be stored in one of your image layers, and thus anyone pulling the image will be able to see these credentials. If your project has a very large and complex configuration, you can mount a configuration file via a Docker volume. This will allow you to set up a configuration file and run it on your system. And if you need to move to an orchestration system such as Kubernetes or Swarm, you can convert your configuration into a configuration map easily. Best practice number 8, working with base images. When choosing a base image for your Docker file from Docker Hub, make sure you select a specific version. Where possible, don't select an image with the latest tag. We saw the consequences of this earlier. When working with Docker base images, choose an image that is up to date and has just the applications that you need. Avoid choosing an image that has a lot of extra applications installed that you will not need. This will have an impact on your host machine's resources and thus affect performance at scale. Finally, make sure you're not pulling a base image from a repository or registry that is not from a reputable or trusted provider. Best practice number 9, installing applications and packages. When installing packages or applications, 1. Make sure you're using the -y switch to make sure the build does not stop and ask for a user prompt. 2. Use the --no install recommends flag to ensure that a sizable number of applications that your package manager has recommended but ideally will not need in your build are not installed. 3. Look for images that will not need to be upgraded by the use of the apt-get update or list upgrade commands. If you really need to install applications using the apt-get command, ensure you specify the specific version you need, as you don't want to install a new version or one that is untested. 4. When building your application from code, remember to clean up the installation files to reduce the size of the image you're creating. For example, if you're using apt-get, you should also remove the lists in the /var/lib/apt/lists path to clean up installation files and reduce the size of your container image. The last best practice for this tutorial series is Docker files must have only one cmd or entry point command. As your image is being created, always make sure you have only one cmd or entry point instruction or command. Finally, let's build a sample complete Python production Docker file with all the best practices we have mentioned. So in your IDE, create a Docker file anywhere you wish. So for me, I've created my Docker file here. So first, we're going to choose a specific version of Python. We shall not be using the latest tag. So I can say the argument for Python version. For me, it's going to be 3.9-slim bullseye. Then I'm going to create an alias for a specific Python version. So I can use the from statement. So I can say from Python, then bring in the Python argument, the version. Then we're going to use the alias, you can say as Python. Then since we're using multi-stage builds, we're going to have another from statement. So from Python, this is going to be our build stage. So I can just call it, I can say as Python build stage. Then we're going to have another argument. So I can say my build environment is going to be production, like that. Since we're choosing to update and install apt packages using apt-get update and apt-get install, 1. We shall use the -y switch to ensure the build does not stop and ask for a user prompt. Then we shall also use the --no install recommends to ensure that the packages recommended by apt, but ideally we shall not need in our build, are not installed. How do you do that? You say run apt-get update and apt-get install. Then we can say --no install recommends, then -y. Then we can say, let's tap this in. We can have dependencies for building Python packages. So we can say build essential, then /. Then we can have libpq -dev. This is for secopt2 dependencies, and that's it for that. Then we're going to install our requirements. So you can say copy /requirements to our working directory. Then we're going to create Python dependency and subdependency wheels. So you can say, and basically wheels allow for faster installations and more stability in the Python package distribution. So you can say run pip wheel --wheel -directory /user /src /app /wheels, then /. Then you can say, you can tap this in, you can say -r, then pass in the build environment, then say .txt. Then now, since we're using multi-stage builds, we're now going to declare the run stage. You can say from Python as the Python run stage. That we're going to have an argument for the build environment. Again, copy that. Here you can say argument for the build environment is production. Then our app home, you can say another argument. It's going to be called app_home. This is going to be /app. Then we can set environment variables. 1, it's called Python don't write bytecode to prevent Python from writing the PYC files to disk. We had seen this earlier. The next one is Python unbuffered. We had also seen this earlier, but as a reminder, it means that Python output is transmitted directly to the terminal without being buffered, which allows for displaying the application's output in real time. Then next, we're going to say env, our environment variables, is going to be build_env. And we're going to bring in the build environment. Good. Then you can say our working directory is going to be app home. Then, as we had said in production, you don't run your container as a root user. So we're going to create another user called, let's say, Django, in a system group also called Django. So you can say run add group system. Let's just call this Django. Then we can say tap this in and say and add user in the system in group Django, then Django like that. Then we're going to install some other system requirements. So you can say build requirements. You can say run apt get update and apt get install -- no install recommends. In this before, then with the -y switch, then have that in. Then we can install secopt2 dependencies like we did before. Then the next one, we're going to also install translation dependencies. You can say get text and netcat. Then remember, in one of the best practices, we should always clean up unused files to reduce the image size. So how are we going to do that? We're going to say and apt get, we're going to purge -y auto remove -o. Then you can say apt, then double colons auto remove, going to auto remove. Then you can say recommends important is false, and we can say and remove recursively. Remember I told you the /var /lib /apt /lists. So here we're cleaning up any unused files, one of the best practices, especially when you're installing and updating packages using the apt package manager. Then next we're going to copy the Python dependency wheels from the build stage. So you can say copy. So as I'd said before, the beauty about using multi-stage builds, you can copy from one build stage to another. So here we're going to copy from the Python build stage, and you're going to copy the wheels. Also you can say /user src app wheels, copy that to wheels. Then we're going to use wheels to install the Python dependencies. So you can say run pip install -- no cache directory -- no index -- find -links is equals to /wheels then /wheels with a star, then /. Then you can say and remove recursively /wheels. Then next, so let's assume we have like a shell script, which is the entry point of our application. So in production, you want to run this not as a root user, but as the Django user already created. So how do you do that? You now say copy -- change ownership is equals to Django user group Django like that. Then let's say there was a script in ./docker / let's say production, then maybe Django, then entry point, and let's say the shell script was called entry point like that. Then we can run the entry point script. Let's just say run sed -i, then with a regular expression, and say s /\, then r $$g run entry point. Then you can say run mod +x, make this executable, the entry point script like that. So this is assuming that you have a shell script that needs to be run as a non-root user. This is how you change the ownership, and then run the script. Then the last thing we need to do is your copy application code to your working directory. So you can say copy, and this time we're also changing ownership from the user Django to the group called Django, passing the app home, the working directory. We're no longer running this as root. Good. Actually, this is wrong. So copy everything. There's supposed to be a dot here to the working directory up home like that. Then we can now make the Django user the owner of the working directory. So you can say run change ownership of Django like that to the working directory. Then we're supposed to switch now to the user Django. So you can just say user is Django, whatever user used. And then now we have, as usual, one entry point. So the entry point is going to be /entry point like that. This is ideally how you'd use the best practices to create a production ready Docker file for Python. So that marks the end of this tutorial. I hope you got value from this. If you are a Python Django developer and want to learn how to build Django REST APIs with asynchronous tasks with Docker, Nginx and more, I have a course on Udemy that covers that. Cheers.